Hello everyone, let's solve some Leetcode today. So today we have Leetcode 127, that is word ladder. In this problem we have been given a begin word, that is the starting word, then we have an ending word, and we have to reach from starting word to ending word. So we will have a word hit and we have to somehow reach the word cog. And we can do this based on these two rules. Every adjacent pair of words differs by a single character. What it means is that I can take the hit word and I can replace a single character inside of it. So suppose that I decide to replace I. So it will give me hot. So this is the word that I was able to reach from hit by replacing I with O, correct? And the second rule simply says that this newly created word must be part of this word list. If it is not inside of the word list, this is invalid. It means we are not allowed to go from hit to hot. But since hot is inside of the word list right here, it means we are allowed to do this transformation. We are allowed to actually replace the I with O and get the word hot. But if we try to do something like this, we have hit and we try to just change the H, okay, to D. So now we have DIT, dit. Now this is an invalid word. Why? Because it is not actually present inside of this word list. We have hot, dot, dog, lot, log, and cog. So only these 6 words are present in the word list and dit is not one of them. So we are not allowed to go from hit to dit. Okay, this is not allowed. So basically what the question is asking us is that if we have some starting word like hit, then how can we reach an ending word like cog? So we can start with hit, then we can go to another word by replacing I with O. So we will have hot, okay, that is present in the word list, so it is valid, we can go here. And then we can replace the H with a D and it will give us dot, okay, which is also present inside the word list, so it is also valid. And then from here we can replace T with G, so it will give us dog word, okay, do you understand it? And dog is also inside of the word list, so it is valid. And from D we can simply go ahead and replace this T with C and we will get cog word, and that is also present in the word list. So do you understand how we are able to go from hit to cog by going through all these words by making a transformation of one character each time? We are not allowed to change multiple characters at the same time. If that was allowed, then I could have just taken the hit word and then replaced all the characters at the same time. Replace H with C, I with O, and T with G. And then I will simply get cog word in one single swoop. Like this would have been an order of one time complexity, and that's why they have just disallowed it to do this. We can only replace one single character at each operation. So that is why first of all I'm replacing I with O, getting hot, then I'm replacing H with D, getting dot, then I'm replacing T with G, getting the dog word, and then I'm replacing the D with the C, getting the cog word. Now how many steps it took me to start from the hit word and then reach the ending word cog? Well, it took me 1, 2, 3 and 4 operations. It means it took me 4 steps, and this is the minimum number of steps that I need to take to go from hit to cog in this particular example. And that is exactly what we need to find out. We need to find out the minimum number of steps we need to take from starting word to reach the ending word. Here in this case it is 4, so 4 is the answer, but in some another example it can be 10, 12 or maybe 1, who knows, right? So that is exactly what we need to find out, the minimum number of steps, which we are basically calling the shortest transformation sequence in the question, but it is simply minimum number of steps. So how do we solve this question? Well, before trying to solve this question, let us try to understand what the question really is. What does it truly represent? So we will have a starting word like hit and we have to reach an ending word like cog. So in order to do that, we have to go through a few words. Like from hit, we have to go to hot by replacing I with O. And here is the magic. Here is something that we really need to understand. So right now we have something called a word here. Okay, this is a word. Now let's not call it a word. Let's just assume that it is something. Okay, we don't have to call it a word, we just say that it is something. And now we have a rule here. The rule does something and then we reach some other place or some other thing. So what is happening is that we have a particular thing, let's just call it a state, and we have a rule that helps us to go from state 1 to state 2. And we know that any state, place, condition or configuration can be called as a node. If you don't understand how graphs work, I have already created a video on graphs that will explain everything that you need to know about graphs ever. Like you will never have to deal with any confusion regarding graphs ever again. So basically here we have a state that is simply a word, and that word is going to be a node. And then we have a rule here that is going to help us to go from one word to another word, right? So what it means is that we have a node and we have rules for movement between the nodes, right? What it simply means is that we have a graph. In graphs, we will have node and we will have rules that will help us to go from one node to another node. Let us try to create a graph of this particular example. We will have the starting node as hit, okay? Then we can go to some other node. So where can we go? Well, I can replace I with O and I can reach hot. So this is one of the word that I can reach from it. Can we reach some other word from hit? Well, there is no other word that we can directly reach from it in one single operation. So we will have to now move on to the next level. So I can take hot and simply replace H with D and I can go to DOT dot. Okay, this is the next word that I can reach. Or I can replace H with L and I will simply go to lot. LOT. This is the another word that we can reach from hot. And now here you can see if we replace D with L, I can simply go from dot to lot. So it means I will have an edge from dot to lot also. And then if we replace T with G, I will be able to reach from dot to dog. So I will have an edge like this from dot to dog. So this is another node that we can reach. And then if I replace D in the dog with L, then I will simply go to log. So I will have another node here, log. And then if I try to replace D with C, I will be able to go to cog, that is our ending word. So basically we are able to create this particular graph starting from the starting word and we have this ending word right here. And now the problem simply reduces down to finding the shortest node from starting hit node to this particular cog node. So I can go from hit to hot to dot, then I can go to dog, and then I can go to cog. So if I take this path, I will have 1, 2, 3, and 4 steps to reach the ending word from the starting hit word. And now that we understand that we are only dealing with a simple graph, we can use something like DFS or we can use BFS to go through the graph and find out the shortest path. But since we are trying to find out the shortest path, BFS is always the preferred way to do this, because if you try to use DFS, we will have to go through each and every path. We will end up going through here, then here also, then like we will have to go through crazy paths, okay, just to figure out which one is the shortest. We might end up going through each and every path to figure out which one is the shortest. So DFS is not really preferred here, okay? So DFS is not something that we use for finding the shortest path. BFS is much better for that. So how do we apply BFS in this particular question? Well, one way is to create an adjacency list and then you apply the BFS on this adjacency list. Now, if you want this kind of solution, you should go ahead and watch the Leetcode video where he is actually explaining you how to create that adjacency list. But creating this adjacency list actually makes the problem a little bit harder to understand for people. So we are going to skip this thing. We are going to skip the whole adjacency list creation part and we will directly figure out the solution. So how can we skip this adjacency list, right? Well, understand that the reason we have adjacency list is to make sure that we understand which node is connecting to which other nodes. Okay, that's the only reason to have an adjacency list. So how can we figure out this thing in some other way? How can I figure out that this particular hit node is actually connected to hot node or some other node? It is simple, guys. I will have the hit node and then I will simply take the H, that is the starting position, that is the 0th position, and then I will replace the H with all the possible 26 characters in the alphabets of English language. What it means is that I will have 26 words after replacing H, and for these 26 words I will check which one of them are actually present in the word list and I will only consider them as valid, which means only they will be connected to the hit. Then I can take the I word and then I will simply keep H same and then I will take the I and I will keep the T same and then I will replace this position I with the 26 characters on the alphabet. So it will give us another set of 26 words and then we will check which of these words are actually present in the word list, given word list here, and we will only consider them as a valid word and then we will take them as children. In the same way, I will just keep the I here and I will just replace the T and that will give us another set of 26 words. And then I will again check which one of these 26 words actually exist in this particular list and only those words will be valid. So in this way, we can take a word like hit, we can replace each character with 26 and we can generate all the words that we need and then we can just figure out how many of those words actually exist inside of this list and only those words will be taken and placed inside of the queue. Okay, only those valid words we will take and place inside of the queue. Word 1, word 2, word 3. Okay, and rest of the words will be ignored because they are not valid. So in this way, we can find out the words connected to the hit and then we will take those words, place them in the queue so that we can go through those words in the next iteration of BFS. Do you understand this thing now? We have everything to run BFS. we have the starting node hit, then we know how to figure out the connected node with the hit, and then we can take those nodes, we can place them in the queue, and then in the next iteration we can take out the w1 and then find out x neighbors, okay, and then place those neighbors back into the queue, okay, and then just keep repeating. And in this way we will be able to perform BFS in this particular question. Now remember guys that the starting word and all the words inside of this particular list will have the same length. It means it will be possible for me to go from this word to some other word in the list. That is not an issue. Okay. So in the starting, we will have a queue, simple queue, and inside of it, we will have this hit word, which is the starting word. So this represents the starting node that we are going to start the BFS from. And right now the length or the level is basically 1. So I will take out the hit and I will try to find out its neighbors. Now I can replace I with O. It will give me hot. Okay. Now if I try to find out some other neighbor, I can try to replace I with A. So I will have hat, right? Is hat a neighbor? It is not. Why? Because it is not present inside of this list. That's why hat is invalid. Then I can try to replace H with D. So is DIT a neighbor? No, it is not a neighbor because it is not present inside of this list. It means DIT is also invalid. And in the same way, many other words will be invalid. And that will leave us with only this word that is going to be valid. So we will take the hot word and place it inside of the queue. So hot is now here. And since we actually removed the hit, so it is no longer in the queue. Now remember that we are going to run this whole thing inside of a loop, and the loop will depend on the length of the queue. Okay, so we will find out the length of the queue. Okay, and then we are going to run a loop on this length. Suppose this is L, and then we will simply say for I is equals to 0 to L, the length of the queue, we are going to run this whole thing. This is going to come here. Why? Because we need to calculate the levels. Okay, so what it means is that I need to process everything on the current level together. Okay, so that's why in the starting when I had only hit, okay, I'm going to run this loop only one time because the length of the queue at that time is going to be 1. And that means I will take the hit, I will take all of its children nodes and I will place them inside here. Okay, and then this for loop will end. This for loop will end, and once it is ended, I will take the L and I will update it to L plus 1. This is the level that I'm talking about. Okay. Then we will go back again to the top of the loop, that is here on the while loop, where we are checking the condition for queue, and we will find that okay, there is still something in the queue. So I will take the length again. I will again get the one length here. So this is going to be one length here again because we only have hot here. Okay. And what it means is that this particular thing represents the second level. Now we are going through the second level of our graph. So earlier we started with the 1, here we updated it to the 2, the level is 2, and now we are going through all the nodes inside of the level 2 in this for loop. And once we go through this for loop, we will have dot and lot inside of this queue, and we will not have hot. So it means we will have 2 new elements and we will update the level here again. So we will have 2 plus 1, that is 3. So on the third level, we will have 2 elements. We will go back to the while loop again. We will take the length. It will be 2 now. And then we will run this for loop for 2 nodes. Then we will take their neighbors, we will place them here inside of the queue, and we will update the level again. And while the loop will be running, we will find the ending word cog, and then we will simply return the level, because this level is going to be the minimum or the shortest path we need to take from the starting word hit to the ending word cog. Since we are going to generate a lot of words from each node, we need to have a way to find out whether those words exist in the word list or not in order of 1 time complexity. So that's why we are first of all creating a word set with this word list elements. This set will help us to find out whether the generated word is present in the word list or not in order of 1 time complexity. Then first of all, we are checking if the ending word is not in the word set. Then we are going to simply return 0, because if it is not in the word set, we will never be able to reach that word ever. So in this case, it will be impossible to reach the ending word, and that's why we are returning 0. Now here we are creating the queue and we are placing the begin word inside of the queue. And the current length or the current level is 1. And then here we have the alphabet string. From this string, we are going to take the characters and we are going to create new words by replacing them. And now our BFS starts. So first of all, we are capturing the level size because that's what we are going to run the for loop on. So we are taking the length of the queue and then we are going to run a for loop on this length. So we are going to process all the elements or all the nodes that are currently present in the current level. Then we will simply pop the word from the queue. We will take the word. If it is equal to the end word, we will simply return the current length or the current level. If it is not equal to the end word, we are going to try and get its neighbors. So here we are running a for loop on each character of the word. We are storing the original character that we are currently on. And then here in the nested for loop, we are taking each character from the alphabet string. And then we are just creating a new character or the new word here with this replaced alphabet character. Now this new word we are going to check if it is present in the word set or not. If it is present in the word set, we will take this new word, we will place it inside of the queue so that we can go through this word in the next iteration of the BSS. And as we append this in the queue, we are going to remove this word from the word set because we don't want to append this word again in the queue in case some other node is connected to it. This is our way of marking this visited. We are not using a visited array, so we are just removing the word from the word set itself. Now here this condition checks if this particular character from the alphabet string is basically equal to the original character. If it is equal, that means we actually got the same word again, so we are simply going to continue in that case. And once this outer loop is done, we have gone through all the words in the current level, so we will go back to the while loop above, and here we will again check the level size. But before going to the while loop, here at the end we are updating the length or the level. So it means after the first level ends, we will update it to the 2 and so on. And in this way, the entire BFS will keep on running, and at the end we will simply return the length. So if we ever find the end word, this condition will be responsible for returning the length. Otherwise, in the worst case scenario, we will end up returning 0 because it will not be possible to reach to that end word. And it is possible to never reach the end word if that end word is actually an isolated node. So if the graph is divided into components, then it is possible that the ending node is actually part of a component that you cannot reach ever from the starting node. So in that case, the entire BFS will run without ever reaching the ending node, and we will come here in this line, ending line, and then we will simply return 0. That hey, we can never reach the ending word with the given starting word. So now let us try to run this and see what happens. So our solution runs in 315 milliseconds, speed 38.30% solutions on Leetcode, and passes all the 51 test cases. So now let us look at the space and time complexity for this particular solution. The time complexity is going to be order of n multiplied by 26 because we have n nodes, and for each of these nodes we are going to go through each of the characters of the word. So the word length can be m, and for each of those characters we are going to replace them with 26 characters of the English alphabets. So that's why we have 26 here. So we have n multiplied by 26 as a time complexity. Then for the space complexity we are going to have order of n, because in the worst case scenario the queue will contain all the nodes given in the word list. And also we are using the word set to check if the given or the current word is actually present in the word list or not. So that also consumes order of n space complexity. In code also you can see we have the while loop that is going through all the nodes. Then inside of this while loop we have this particular for loop that is going through each and every character of the word. So the word length can be m, and then for each of these characters we have this for loop going on inside, that is 26 character for loop, because we are going to take all the 26 characters from the English alphabet and we are going to create new words with those characters for the current word. So basically the while loop is going to run for n times, the for loop inside of it is going to run for m times, and this entire nested for loop is going to run for 26 times, which is giving us m multiplied by n multiplied by 26 time complexity. And here in the starting we have the word set and the queue, which are going to give us the space complexity of order of n. So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, just let me know in the comments. Now we will meet in the next video. Till then, bye.